Okay, so we've been talking about percents. Today we're going to look at some very common applications of percents. The first one we're going to look at is commission. Now we mentioned the proportion method. We use the proportion method for most of our percent problems. It works great for our word problems because pieces of the word problem fit in with the proportion. For example, let's say that I'll be creative with my names. XYZ Corporation estimates monthly profits as 12% of gross sales. In a month where profits are estimated at $180,000. What were gross sales? Now, as I said before with the other simple percent problems, if we have a percent, you always start. In fact, even if we don't have a percent, you always start out with the percent. So in this problem, where would we start? 12%, which would be written as 12 over 100. Now let's identify what each of those things stand for. What does the 12% stand for? What does the 12 stand for? Estimated profits. And what are those profits estimated as a part of? They're estimated as a percent of gross sales. So the 100% represents gross sales. So now on the other side of our proportion, things just have to fall into place. The only other number in the problem here is $180,000. Does that represent estimated profits or does it represent gross sales? Estimated profits. So does that number go on top or bottom? The estimated profits are on top. $180,000 goes on top. So we're looking for this number. So we shall cross multiply and divide and get $1,500,000 in gross sales. Pretty simple, right? So using that proportion whenever possible, to me, makes life a lot easier. Yes?
Is it possible to run out of room on your calculator so it just like stops?
If it gives you something like 1.5 E6? No?
It just wouldn't let me enter a 0.
Really?
Yeah.
Let's see what calculator you have. That one should have a pretty long digit limit. You should have no problem with that. Make sure you clear it off, shut it off, and turn it back on, and make sure it's cleared. Okay. Cross that off. I don't need to explain that. However, the proportion is a little tedious, and if you have a calculation that you're doing over and over again, it can be useful to use that rate method or that equation that we talked about. One example of this is commission. Yeah. In a commission issue, generally commission is when you're working on sales, although sometimes it can be a value-based production commission, a little more complicated. We're going to stick to sales just because it's the simplest way to discuss commission. So in a commission situation, your pay is based on a percentage of your sales. So for example, let's say you're getting a 9% commission and you have sales for the week of, let's go with $3,800. Well, you could find your commission as 9 over 100 sales blank over $3,800, and you cross multiply and divide, which is going to be what? $342, I believe. But again, if you had to do that every week, it's a little tedious to set this up. So what you can do alternatively, what you can do is just take your sales of $3,800 times your percent commission. 9% is going to be written as a rate, which would be 0.09. So $3,800 times 0.09 gives you $342. Now what we just did there is what's called a straight, sometimes called a pure commission. That's not always the case. There are other cases, incentive-based or otherwise. Let's start off with a base plus commission. So sometimes called a salary plus commission. And a salary plus, let's say you're working in a place where you're not always guaranteed to have enough sales to make a decent paycheck every week. So what they do is they give you a guaranteed paycheck. Then you get commission on top of that. Now, one of two things usually happens. The first possibility is you get just a much lower commission rate. For example, like this. You might work in a place where you are guaranteed $300 per week plus 3% commission on sales. So let's say you have a week where you have sales of $1,600. Your commission is going to be 1,600 times 0.03, otherwise known as $48. And of course, on top of that $48, you're going to get the $300 salary, so your pay for the week is $348. So in this case, the commission is used you're guaranteed you're going to get a salary. You're guaranteed $300 an hour, or $300 per week. The commission is used more as an incentive to perform better on your job. Now, another way that this is sometimes done rather than a salary plus is sometimes a wage plus. You might get an actual hourly wage plus commissions on sales. I'm going to assume you guys can calculate hourly wage, so we're not going to get into that. Now, another way this is done, the salary plus type deal, is you might be expected that for your salary, you're going to have a certain amount of sales. So, for example, you may get a guaranteed $250 a week salary plus 8% of sales over $1,500. So in this case, they're assuming that for that first $250, that you should get about $1,500 in sales. Now I realize the percents won't work out there, but still, they're not going to give you anything for that first $1,500 in sales because they already gave you the $250. So let's say you have a week where your sales are $4,200. First of all, how do we find your commission? Yeah, we take the 4,200 minus the 1,500. So you're only going to get commission on $2,700. .08, very good. So you get $216 in commission that week. Now, of course, to that, you're going to add your $250 salary, so you get $466. Correct? Okay. Now, another possibility is you might have a graduated commission. For example, your commission might be 8% on anything up to $4,000 and 11% on anything over $4,000. So you have this incentive to have a really good week. If you go over $4,000, you're going to get even more commission. So let's say you have a week where your sales are $5,600. To figure out your commission, you got to split that up. $5,600 is going to get split into the first 4,000. And then how much is left after that? 1,600. That first 4,000 is going to be times what? 0.08, which is going to give you $320. The 1,600 is going to be times 0.11, which is going to give you $176, which comes out to be $496. So there's all sorts of ways that the commission can be done. Now, just because there are some of you that may end up in sales, I don't know if any of you are in the marketing program or anything like that, but I do want to show you something. This was a huge scam back in the 90s. Sure, you bet. And especially in the insurance industry, it was a huge scam. But other industries used it as well. If you were working a job where your commission was solely based on sales, or your job was solely based on commission off of sales, people would get nervous about that. Because it always took you a little bit of time to get good at it. So they didn't want to have those first few weeks where they didn't make enough to survive. So let's say that they gave you a 12% commission with a $600 guaranteed weekly draw. Draw.
Yeah, what is that? Is that
Well, you're going to find out in a minute.
Oh.
Now that looks pretty good. $600 a week guaranteed. That's like $31,000 a year. That's not bad, especially in the 90s. But it didn't work out that way because people didn't understand what that draw word meant. So let's take a week one. Let's say we have sales of $3,500, which isn't bad for your first week. Your commission is going to be $3,500 times 0.12, which is going to be what, $420 is your commission. Is that correct? How much are you going to get paid? $600, guaranteed $600 a week. But you only earned $420. 600 minus 420 is $180 that goes into what they call a draw. Say week two, your sales go up. You have 4,200 in sales. Commission, 4,200 times 0.12 is going to give you $504, right? How much you can get paid? 600. But again, you only earn 504. Another $96 goes to that weekly draw. Now let's accelerate the process a little bit. Usually you wouldn't be doing this well in your third week, but let's just say in week 3, you sell $6,000. Your commission, 6,000 times 0.12 is going to be a $720 commission. How much you can get paid? People are going to say, I'm going to get $720. Woohoo, I'm in the money. You're going to get paid $600. Why? Yeah. Right now, you owe $276 on your draw. You made $120 over that. You're going to take $120 off of that, which means you're down to only owing $156 on your draw. Now you can see this isn't a bad deal if your sales go like this. After a few weeks, you get it paid back, and you are making that full commission. There are a lot of people though that get into sales and insurance, especially. I'm not trying to single an industry, but that was just the most common one. They'd get 4 or 5 months into it and realize they suck at sales. Well, at 4 or 5 months, this could be $10,000, $12,000 that they owe on that draw. Guess what happens if you decide to quit? It's basically just like a loan you have to pay back. So they're pretty much trapping people into working for their company. Okay, let's switch gears a little bit. Let's talk about interest. We've mentioned interest a little bit before. We're going to talk about simple interest first of all. In simple interest, the amount of interest follows the formula I equals P times R times T, where P stands for the principal, which is just the starting amount. It's the beginning value of whatever you borrowed or whatever you put into an investment or whatever. R stands for rate, which is just the decimal version of a percent. So 8% would be a rate of 0.08. And T stands for time. Time is always in years. If there's no symbol between them, it's always multiplication. And of course, I stands for the dollar amount of interest. So let's say we want to know how much interest we would earn on a $4,000 investment invested at 6%. Let's make it easier on myself. Let's do it with that. For 3 years. So the amount of interest is 4,000 times 0.06 is 6% as a decimal, times 3, which is going to give us what? What's $720 in interest? Is that right? So $720 in interest means at the end of those 3 years, we would have the 4,000 plus the 720, or a balance of $4,720. Now that's fine, except most places, if you're investing for 3 years, they won't do simple interest. If you're investing or borrowing for more than 3 years. Usually if it's more than 6 months, they do what's called compound interest. Compound interest is where every so long of a period of time, they figure out the interest and they add it in. So for example, let's look at that same example, $4,000, still for 3 years, but this time the interest is 6% compounded quarterly. Quarterly implies how many times a year? 4 times a year. If they're doing it 4 times a year, how many times are they going to do it in the course of 3 years? 12 times. So we take a look here. Let's look at quarters. Quarter 1. The amount of interest is going to be $4,000 times 0.06. What's our time going to be? We said the time was always in years, right? A quarter is 1/4 of a year. It comes up to $60 in interest. Now adding that $60 on means we start quarter 2 with $4,060. So the interest in quarter 2 is 0.06 times 1/4, which means we're going to have what? No. $60.90 interest debt. Why is it more?
Although you did know it's
extra $60, so you got it. So if we add that on, it means we start quarter 3 with $4,120.90. Well, as we mentioned before, how many times do we have to do this to get through 3 years? 12 times. I don't want to do it 12 times. So let's look for a shortcut. First thing I'm going to look for is this right here. 0.06 times 1/4 is 0.015, otherwise known as 1.5%. Which makes sense. If it's 6% annually, but you're dividing it up over 4 quarters, 1/4 of 6 is 1.5%. That makes sense, right? So what we're really doing is we're looking at 1.5% every quarter. Now, we talked briefly about percent increase or decrease. We could find the 1.5% and add it on, or we could just find 101.5%. That would be the full amount, the 100% plus 1.5%. Make sense? Let's say the first quarter we took the $4,000, right? That's 100%. To it, we're going to add $60. That's the 1.5% interest. At the end of that first quarter, we have $4,060, which is 101.5% of what we started with.
Why is it 1.5%?
6% divided by 4 quarters. So what this means, if we go back to using the rates, what we could do is this. To get the balance at the end of the first quarter, 101.5 as a rate is just 1.015. Gives us $4,060. Take the 4,060 times 1.015 again gets us $4,120.90, and keep going. How many times do we have to multiply by this number? 12 times, right? 12 quarters. If we're multiplying by the same number over and over, we have a shortcut in math for that. What is it? A power. Good. We just go to the power of 12 to get through the whole 3 years. So 4,000 times 1.015 to the power of 12. $4,782.47. Which is about $62 more than what we had with the simple interest. So there's more interest on it with the compound interest as well. Now, where this compound interest thing becomes really huge, now I realize this is a little bit of an older demographic in this class, so this won't be quite as relevant to some of you. But let's say you get out of school and you're 25 years old. And you get that first good job, making good money. A lot of people, they want to buy a newer car or move into a nicer place. They want to spend that money since they've got more money coming in. But what if you stayed living like you were when you were in school? Living cheaply, you'd have more money coming in. How much money do you think you could save in that first year? A lot. I'm going to go with like $5,000. But you could probably save more if you really wanted to. The only reason I'm going with $5,000 is 1, it's a nice even number. 2, federal government says that's how much you're allowed to put in an IRA, a retirement fund every year. You can put more in other investments as far as just an IRA, an individual retirement account. That's your limit per year. What age do most people retire at? 65. Actually, they've already said for people my age, minimum retirement is going to be 67. So for many of you that are younger than me, it's going to be 68 or 69. But let's go with 65, which means you're going to have 40 years. Interest rate, you might not believe this, considering right now you can put your money in the bank and get like 0.25%. Or if you leave it in for like 3 years, you might get like 0.75% interest on it. But if you invest in stocks and bonds and mutual funds and stuff like that, the average return on long-term investments, that's any investment of 20 years or more over the last 150 years since the stock market started, has been over 13%. That's during periods that even included the Great Depression back in the 20s and 30s. So if you're investing for a 40-year period, you can make 12 or 13% a year average over that period of time. But let's go conservative. Let's just say we're going 10%. So what would the value of this $5,000 be after 40 years? What's $5,000? 10% means we're looking at 110% at the end of every year. We're not going to compound quarterly. We're just going to go at the end of every year. So that's 1.10 is 110% to the power of 40 because we're going for 40 periods, 40 years. Anybody want to guess? Not quite. Nope. Basically 226,000. A little less than $250,000. Now you may think, that's not enough to retire off of. That was one $5,000 payment at the age of 25. Imagine if you did that every year for 5 or 6 years. You would be a millionaire when you retire. Now let's say you screw up and you get to be my age. Now I'm 41, but let's say I'm 40 just to keep it simple. So that $5,000 is only going to be in there for 25 years. Anybody want to guess?
It's going to be a lot less.
I guess how much less? 54,000. Less than 1/4 the value. That's significant. Now that's at 10%. At 12%, that becomes it's about 1/6 or 1/7 the value at 12% interest every year. This is huge. A lot of people have it backwards. They get that first good job, they're making money, they have toys they want to buy. So they spend 5, 6, 7, 8 years buying their toys and partying and living it up. And then at 30 or 35, they start saving for retirement. But if you did it the other way around, bless you.
So you're saying they saved all their money when they were 31.
There you go. Here, let me show you this. I can put together a quick spreadsheet here. So let's put in your age, your contribution, and your balance. Let's start at 21 for just the heck of it. Because there being 2-year programs, some people might get out of here at the age of 21 and get a good job. Let's put in $5,000 a year contribution. We're going to stick with that 10%. Anybody want to guess? That comes up to about $3 million right there. $3.5 million to be exact. Now let's do this. What happens if you decide, you know what, I'm going to screw around for a few years? What do I do? Like 1, 2, 3, 7 years. Let's go 8 years just for the heck of it. You want to buy 4-wheelers and new cars, new trucks, whatever, snowmobiles. So for the first 8 years, you spend your money. At 29 or 30, you decide, you know what, I should start worrying about retirement now. I should start saving your money. Anybody want to guess?
I'm going to say not even $1 million.
A little over $1.5 million. You've cut this into less than half.
I'll put it in your age.
Starting at my age, we'll get to that. I want to show you this one next, though. Oops, right here.
Are you later? Early?
Shh, you're giving away the punchline. Let's say you do this instead. Start at 21 and you save all your money until you're 29. Then you decide at 29, you know what, I've saved enough, I'm going to party. You come on, way ahead.
What?
To answer your question, it's not fun anymore.
You can't enjoy it anymore when you're later.
It's
Anyway.
no fun anymore. And this,
I would say at 30, you could probably still enjoy your life a lot. But this first 8 or 9 years when you're young, in fact, let's take the 29 out of it. Make it exactly 8 years. You're still way ahead. That first 8 years when you're young, this person only put away the money for 8 years. This person here put away the money for 32 years, made less. That first 8 years is worth more than the rest of your life.
I don't get how that.
Just because it's been in the money thing that they're younger.
It's the
than?
compound interest.
Huh.
This first $5,000, as we saw, let me do it over here easier. That first $5,000 is worth $331,000 in your retirement account. But let's say we do this. That $5,000 you put in at 30 is no longer worth $330,000. It's only worth $140,000. Put in $5,000 at 40. It's only going to be worth about $54,000.
So
The value of that money goes down every year. So the money you put in when you're young is worth literally 5-6 times as much as the money you put in at 40.
So if you put your money in the first 10 years of your life, you should have somewhat decent.
If you put away $5,000 a year for the first 10 years of your life, you'll be in good shape. In fact, I used to have, I worked in the financial industry for like a year and a half. I was frustrating because people don't want to listen. When it comes to their money, people think they know what they're doing. They just expect you to confirm what they think and then do it. I'd have people that would come to me. They'd have a child who was like a sophomore or junior in high school, 15 or 16 years old. And they'd maybe save $9,000, $10,000 for their college fund. They wanted to know what they should invest that money in to help their kid pay for college. They would get mad at me because I'd tell them, don't let them use it for college. Because I'll use the same algorithm here, we'll just clear it out. Let's do this. Damn it. Here, we're gonna do it.
All the funds paid off.
Just give me a second here, man.
Okay.
Let's start this at 16. Federal government says you can start putting away IRA contributions at the age of 16. The only catch to that is you cannot put away more than what you earned. So let's say you only make $1,500 that year, you can only put away $1,500. But here's what I advise these parents to do. If your child starts a part-time job or whatever at 16, let's say they make $1,850 that year. You put away $1,850 for them in a retirement account. Retirement accounts don't count against you for financial aid for college. College accounts do. Let's say at 17, this person earns $2,700. So you put away $2,700 in a retirement account for them. Match what their income is in a retirement account. At 18, let's say they made $3,100. Now you still haven't used up that whole $9,000 or $10,000 yet. But here's what you've done for your child. At the age of 65, they'll have almost $750,000 in retirement. Now let's do this here quick. I just want to see. So right now there's $7,650 put away, which means there's another $2,350 left that you could put away. So let's say that you put away that last $2,350 at 19. Anybody want to guess where this kid is sitting at 65 when they retire?
$5 million?
Right around $1 million. So to me, it's more valuable. I would rather have my child borrow money to go to school. They've got the rest of their life to pay back that student. Now I know people are, you telling me to put my kid in debt? Oh my God, what a horrible thing. But they've got the rest of their money, the rest of their life to pay back that student loan. Chances are $10,000 is only going to pay for the first year and a half, maybe 2 years of college, if that anymore. They're still going to have to borrow money anyway. So they're going to spend 6 or 7 years paying back that loan. Then they're going to start saving for their own retirement. Maybe. If they do this, that's really close to having their retirement set. To be honest, if I had $921,000 in the bank right now, I'd retire tomorrow. Dead serious.
So you didn't take your own advice then?
I did, but
It's impossible.
I'm just saying if you have the means, it's a good idea. I mean, I knew about it and I started it at about 16 or 17. By the time I was 23, I had almost $30,000 put away. I would have been sitting really well in my retirement. But then I got married and I was convinced to take it out to build a house and stuff like that. Probably not the best decision I ever made, but I did it. So, yeah, sure. Okay, so anyway, we're going to leave that
The
out.
life insurance counts against you, right?
No,
It doesn't.
no, life insurance is doesn't count against financial aid and it's non-taxable. So that's why if you have a lot of money, what is it like? Is it 1 million or 1.5 million now that you can pass on to the next generation without paying inheritance tax? If you pass on more than that, you have to pay taxes on your money. What a lot of people will do to avoid that, if they know they're sick and they're dying, they'll actually, they call it a single payment life insurance policy. Where let's say you have $3 million, you can take that $3 million and buy this life insurance policy. The life insurance policy may be only $2.8 million. So it's going to cost you $200,000 to buy the policy. But then that $2.8 million goes to whoever you named as the beneficiary. No taxes, no probate, none of that. Taxes on that would probably be about 45%. So you would have lost like 1.3 million of it to taxes if you hadn't done it. So that $200,000 commission is pretty cheap. So there's a new quiz due Tuesday. New homework due Wednesday. And test 3 is also in class on Wednesday. And then Thursday, there is no class. I hope to be in Philly by Thursday. So.